Okay, so we're going to go transforming quadratics. They told us that a water balloon is being thrown, and this is the relationship that represents it. Now, they've given us two variables. D is distance, and it's also the variable in the equation here. And they're technically both in the equation. And height. What they've done is they've set this equation equal to height. So in order to solve for height, we have to plug in values for distance. And every time we plug in a value for distance, we're going to get a new height. So they've given us 7 different values for distance, okay? And they want us to complete this chart. What we'll do is we'll go over the first one. So the very first one, which is what we were just talking about, is initial height, right? Initial height would be the distance from where he threw it would be 0. It's still in the person's hand, he or she's hand. So what we're going to do there is write the same equation, h is equal to negative 6.2. But in this one, we're actually going to be replacing, these are our x values, or our d values. We're going to replace d with 0. So just the d itself. D disappears, and a number takes its place. Same within this one. D disappears, and a number is going to take its place. Now, because we're using the number 0, it's actually an easy one to equate. Probably don't need a calculator. But what we'll do is we'll do our bed mass first. In bed mass, we always deal with our exponents first, right? So what would 0 times 0 be?
0.
That's right. So we get negative 2.6 times 0 squared is still 0. What is 0 times 7.8?
0.
Yeah, it's still going to be 0. 0. And then we just bring down our other number, plus 21.5. And same idea, negative 2.6 times 0?
0.
Yeah, that's right. So we're looking at 0 plus 0 plus 21.5. What's that mean?
The height is 21.5.
Yeah, so this is in meters. I highly doubt this person is 21.5 meters tall. So if we were to have to try to put an explanation to this, we're probably talking about somebody standing maybe on a bridge or a cliff or something, and they have their water balloon and they're going to throw it off the cliff. That's the idea. Right? Does that make sense?
Yeah.
Now, what they want you to do is the same method for the rest of these. Okay, so you have 6 more to try there. All right, so you went through the other ones, 5.4, 7.35. We got to 8. It looks like 8 is going to be what? Yeah, it's going to be the highest point. And we've started to discover a pattern. It's starting to drop by the same one. So we can probably fill in the other ones with educated guesses. This is going to be 5.4, and this is going to be 2.15. And when I calculated them, that's exactly what they were. So we figured out that there was a pattern to this. Now, these numbers they've given us, they actually represent coordinates. Okay, so we can write them like xy coordinates. And what we're going to have to talk about actually is which one we're going to make our x and which one we're going to make our y. Could be vice versa also.
D is going to be x and h is going to be y.
Yeah, that makes sense, right? Because we're talking about h as in height above the ground, which would most likely be up and down. And d they said was a horizontal distance, so that would be left and right. So if we were to make a small chart here, actually I'll bring up a chart. So we have our graph here. And what we're going to do is we're going to plot each of these as points. We'll zoom back in and make the points again. So our first point here is 0 and 2.15. Our next point is 0.5 and 5.4. Our next point is 1 and 7.35. The next one is 1.5 and 8. 2 and 7.35. 2.5 and 5.4. And finally 3 and 2.15. Okay. So we have all of these coordinates. Let's go plot them so we can try to make sense. A graphical representation or a picture usually helps a lot. So we said the very first one, now we're not going to be 100% accurate here. We're going to make it a rough sketch. But it was at 0 and 2.15. That's probably about there as our first point. The next point they gave us, I think, is 5.4 and 0.5. Is that right?
0.5.
Yeah. Okay, so 0.5 would fall about here. And 5.4 probably falls in here. So like bingo, we connect the two dots. Our next point at 0.5 and 5.4. Then the next one we had was 1 and 7.35. Good. Okay. Probably about there. 1 and 7.35. And then finally 2 and 8 was our peak. And then that pattern continued, right? Wait, was that right? Is it
1.5
1.5 and 8? Yeah, sorry. One little mistake there. 1.5 and 8. There we go. All right. So our vertex, it looks like, is 1.5 and 8. And then, like we said, our pattern continued going down to about at 3. It was at 2.5 again. Okay. So we have these important points. And we're going to kind of connect the dots here. Goes up, over, down, and it's going to continue this pattern, right? So in this question, they also asked us,
what is the initial height above the ground?
okay, which we figured out that was the initial height. The height was 2.15 meters was the initial height above the ground.
And to write a relation in form y equals a bracket x minus h bracket squared plus k.
Now, do you know what this form is called? A specific name for it, which helps with. What's that? Not quite. There's actually 3 different forms for quadratics. I think you guys are going to get into it a little after, but this one's actually called vertex form. Okay, so this is good to remember. This is called vertex form, and what they actually have up here, the original one, that was in standard form. And our other major one that we usually talk about is something called factored form. Okay, now standard form looks more like this. It's ax squared plus bx plus c. Those are the letters they use to represent it. I'm not sure if you've seen that before. And if we quickly look, we can actually figure out, just looking at it, my a in this one would have been negative 2.6. My b would be 7.8. And my c would be 2.15. Okay. Now, vertex form. Vertex form is a little different. And just for a side note, I'm going to put in factor form just so you know it. And just so we can tie something else to it. Factor form, again, is y equals x minus r, x minus s. Whoops, I didn't mean to put that s there. I want them to both be the same color. We'll make those both blue. R and s. And again, there's an a. So if you notice in all 3 of these forms, there is a unknown represented by a. And that a is actually going to be the exact same in all 3 of these forms. Okay. So what was our a in our standard form?
So, well, a was d.
A was the number in front of d.
Oh, okay.
So what was that number then?
Negative 2.6.
Yes. So to go into vertex form is quite easy actually for us. I can right away go, oh, okay, well, I know my a value in vertex form is going to be negative 2.6. Okay? So we have that already. Then from here, x minus, now our h value and our k value. The reason they call this vertex form is because the vertex is in the equation. Okay? And what that means is the x value of the vertex and the y value of the vertex are actually represented by 2 letters.
H.
Yes, exactly. Our h and our k. So what was our vertex? Looking at this graph, we've solved it.
8 and 1.5.
So 1.5 was our x value and 8 was our y. So what would be our h?
H would be 1.5.
Yeah. And what would our k be?
8.
That's right. So what that means is I'm going to plug those numbers in. For my k, I plug in the number 8. And h, if you look, is 1.5. Now remember I told you it's always going to look opposite? The reason being is because there's a negative there. So it looks like it's negative 1.5, but
It's actually positive.
it's actually positive 1.5. But in the equation, it kind of looks backwards. So when we go to write it in our vertex form, it was actually quite easy since we already had the standard form. Our vertex form, I'm going to write it all in black here, okay? Y equals negative 2.6, x minus 1.5 squared plus 8. So there's our vertex form. Now, I want to draw your attention to one other way we could have done this. Okay? Another way we could have done this is by doing a couple equations, from calculating some stuff. Now again, our vertex we would have found the same way. We knew that this was our vertex, 1.5 and 8, so I would have plugged 1.5 and 8. But maybe I never really knew this rule about the a's. Okay? Maybe I had never been shown that. We could still have calculated what the a would be. So I'm going to go down here and just give an idea of how to calculate this. Y is equal to, and like we said, x minus, it's 1.5, right? And right in blue is our h. And our 8 was our k. But we still have an unknown, a. Well, actually, technically x and y are unknown, but they're part of the equation. When we go to write it, there's still going to be an x and y. We need to figure out what our a is. Well, in order to do that, I can plug numbers in for x and y. And the numbers I plug in just need to be coordinates on this parabola. I can choose any coordinate and solve. So I actually have many to choose from. I can choose these guys, these guys, these guys. Now we're not going to re-choose the vertex. That'll be the one coordinate we wouldn't use because we've already put the vertex in the equation. But any of these pairings that we've written, so any of these pairings above, would represent the x and the y in the equation. So we're going to grab one. Let's use, I guess let's use 1 and 7.35. 1's a nice number to work with. So they're going to represent x and y. So what that means is I'm going to go down to that equation. Like that coordinate in above. It was 1 and 7.35, was it? Okay. That's going to be our x and our y. Or in other words, I'm going to replace x with 1 and y was 7.35. So this equation now reads 7.35. I replaced y is equal to a. 1 is going to replace the x minus 1.5 squared plus 8. Okay. Now there's only one variable left, which is our a. We're going to solve for it. So we're going to try to carry out our bed math.
So do you have to isolate a now?
Yeah, we have to isolate a now. So I still have 7.35 is equal to a. Now I deal with brackets first. 1 subtract
1.5 equals negative 1.5 squared, so negative 3.
well, negative 0.5 squared.
Oh,
Yeah, that's right. Get rid of 1. And then let's figure that out. 0.5 squared, 0.25. And I know it's going to be positive because technically it's a negative times a negative. So it's going to be 0.25. So I know we're working with some decimals. We end up with 0.25 plus 8. Now, this sometimes gets confusing. This still says a times that. And according to BEDMAS, I would deal with this before I would do any addition here. So what would 0.25 times a be? Sorry, not ab. That sounds confusing. What would 0.25 times a equal?
0.25a.
Yeah, exactly. So we're left with 0.25a. That's another way to represent it, plus 8. Now we've done as much simplifying as we can. We have to isolate. So in order to isolate, you kind of talk about reverse BEDMAS. And I'm going to now deal with the positive. I'm going to move 8 to the other side of the equation.
So negative 7.35 minus 8.
Yeah.
Equals 0.2.
Good. 0.25a. That's going to give us 7.35 subtract 8. Negative 0.65. Is equal to 0.25a. And finally, how do I isolate this a here?
Is negative 0.65 divided by 0.25 equals 0.25 divided by 0.25.
Yeah, that's right. Now, I think I've talked about this with you before. They usually say that these cancel out. Technically what it is they create the number 1. And when 1 times a is just going to be a. So we say they cancel out because they become no longer relevant in our question. Kind of is canceling out, but really it's creating a 1. Yeah. So the question is now going to read a is equal to, and when we figure this out, negative 0.65 divided by 0.25 gives us negative 2.6, which is exactly what we had originally found for our a. I know it's a big page here. We did quite a bit. The easy way to solve this is to know that in standard form, that's still going to represent our A. But say we didn't, say they didn't give us standard form, they only gave us the vertex, we could still solve it by doing that. Vertex and another point. Okay, so that's how we put that into vertex form, and we were in standard form to start. Okay, here's another example. We've altered our graph a little so we can start at higher numbers. Okay, now technically if we drew this in a real graph, this is going to be really far to the right if we started at 0 and very high up if we'd started at 0. We're already at 1500 here. Now, I want to draw your attention to this here, these y values. Okay. Now, if you remember in the other example we did, and we'll jump back to that page for a second, okay, our y values, they ended up being symmetrical. 8 was obviously our vertex, and then it went back down to 7.35, 5.4, 2.15, right?
Yeah.
But in the next one, oops, on the next page here, our y values aren't symmetrical. 890, 19 seems to be our highest, and then it drops to 1870. What it's probably saying is the vertex is maybe something like this here. It might actually be in between if we were to actually make a curve of best fit. It might actually be something like that. Now, because we're just trying to do an educated guess, and to make it easy for ourselves, we'll draw our line of best fit. To make it easy for ourselves, we'll probably go with this as the vertex. But the real vertex of this, it might actually be like 1905 and maybe 48, something like that, for all we know. But again, like I said, because they want us to make something in vertex form, y equals x minus k, our a, h, and our k, we're going to stick to nice numbers here. Now, how do I plug these values in for the vertex here? Which number would be which?
So 50 would be H.
Yep, that's right.
1900 would be K.
Good. So, what would this read? Y equals?
A.
Yep.
Bracket. X minus 50.
Yep.
Squared plus 1900.
Good. Now, I have to solve for A. I remember we talked about this in our last example. They've given us a standard form, but they actually haven't given us anything this time. So how do I solve for A now?
So,
How many variables are there right now in this equation?
2,
3, right? We have an X, a Y, and an A. In order to solve, we need to bring it down to one variable, okay? What do I have knowledge of?
Y is 1900.
Okay, for our vertex, though. I want to find a different Y, something different than our vertex. Are there other Y values on this parabola?
Yeah.
There's a lot of them, right?
So let's use 1540.
You want to use
15?
15?
No, 1800 would be easier.
Yeah, probably. Either will work. Doesn't matter, okay? As a Y value, okay. And what would be the corresponding X value then?
60.
Yeah, that's right. I could use that. Or, like you said, we could have used this as the X and the Y. Both will give us the same answer. Okay? So let's plug those in. Our Y value is now going to be 1800. And our X value is going to be 60. We'll still have A is equal to minus 50 squared. So why don't you walk me through this? What next? Corner of bed mass, what do we deal with? Yeah. So let's deal with those brackets.
So 60 minus 50 squared. So 50 squared is 50.
Ah. What you're doing is you're jumping ahead and dealing with the exponent. Just deal with inside the bracket first. What is that going to equal?
Negative 10.
10. Just 10, yeah. Just got to deal with that first. It's a lot less complex than it seems.
Sometimes 10 equals 100.
Yeah, that's right. Okay, so you're already flying ahead of me. Hold on. 1800 equals A times 100 plus 1900. Now what?
Get A to be with 100.
Yep, so how would I rewrite that?
1800 equals 100A
Good.
minus 1900.
Okay.
And then 1800 minus 1900.
Good. So we're trying to isolate A. We bring this guy over. What's that going to be?
So 1800 minus 1900 equals negative 100.
Okay. Tell me what would be on the right side of this equation still after I brought 19 over.
100.
Okay, good. And then that's going to equal what?
Negative 100.
Is going to be equal to
100.
okay.
And then divided by 100.
That's right. We're going to divide this by 100 and this by 100. Good. A equals negative 1. So, how do I write this equation in vertex form?
Alright, so y equals negative 1 bracket 10.
Well, sorry. I want to keep these colors the same. Bracket. Now, do we need to write the 10 in? What was the equation?
Oh, x
Yeah, there we go. X.
minus 50
Good. That's our H.
squared plus 1900.
Good. That is the vertex form. That's the answer they're looking for. Okay? So that's one of the examples where we didn't know the A and we had to actually go about finding it.